This is problem number 7 from section 5.6. Solve the logarithmic equation. They give you a log equation. On each side you've got a natural log. Now to solve this equation, we're actually going to use some different log laws here. To start, because I see I have natural log on each side, I know I can cancel the natural log if I make the logarithms into exponentials. But before I do that, I have to take care of this 2. So this 2 is out front being multiplied times natural log x. I know that that's 2 is really an exponent that was brought out front. So I can actually do the reverse log law on 3 and take this leading coefficient and put it in the exponent. So I'm going to say that this is natural log x squared to start. And that equals natural log of 4x plus 1. Now I'm going to focus on log law 5, which says if I have a log of some base and I write an exponential with that base and then the log being the exponent, that cancels and leaves you just the stuff on the inside of the parentheses. So I'm looking to just have x squared left. Well, what's the base for natural log? That's base e. So I'm going to use e as the base, and I'm going to raise e to the natural log x squared. And if I do it to the left side, I'm going to do the same thing to the right side. So e raised to the natural log 4x plus 1. Now this comes back to our log law 6, which says log base b. Well, sorry, I got screwed up there. Log law 5, which says that they cancel. So this e to the natural log cancels, and this cancels, leaving you just with x squared equals 4x plus 1. I have a quadratic. I want to solve the quadratic. I better get it equal to 0, so I subtract 4x on each side. So x squared minus 4x equals 1. I'm going to subtract 1, so we have x squared minus 4x minus 1 equals 0. Now I look at this and I'm thinking about factoring. I can't factor it because 1, there's no way to add or subtract 1 to get negative 4. So this is where we're going to have to use the quadratic formula. So I'm going to put the log laws away for a little bit because we don't really need them now. Let's use the quadratic formula on this. Negative b, which is negative, so x equals negative 4 plus and minus, and then root negative 4 squared minus 4 times a, which is 1, times c, which is negative 1, all over 2a, which is 1. This gives you 4 plus and minus. Now let's plug all this in. That's negative 4 squared. So I'm going to plug in negative 4 squared minus 4 times 1 times negative 1. That's going to give you 20. So I end up with root 20 here. All over 2. Now I'm going to start to simplify this. I know root 20. 20 breaks down to, let's go root 20. We know root 20 breaks down to root 4 and root 5. And we know root 4 is 2. So I can actually write this as 2 root 5. So I'm going to write root 20 as 2 root 5. So that's 4 plus and minus 2 root 5 over 2. Now I'm going to split this, so it's going to say x equals, this will be 4 over 2 plus and minus 2 root 5 over 2. And that's going to give you 2 plus and minus root 5. So our solutions are x equal 2 plus root 5 or x equals 2 minus root 5. Now, one thing we always want to do here is we want to check our answers when we get the two solutions. So let's go ahead and check our answer. We got 2 plus root 5 and 2 minus root 5. Let's go ahead and plug this in. So I'm going to use my calculator to check these. And I'm going to say that 2 plus root 5, I'm going to store it as x. So 2 plus root 5, enter, and then I'm going to say store it as x, and then I'm going to type that equation in. So 2 natural log x, and actually if you make this easy, we subtract the natural log over, and that would be equal to 0, right? So I'm just going to say minus natural log of 4x plus 1. Just makes my life a little easier. And if this is 0, it's a solution. It is 0. So we know that 2 plus root 5 is a solution. This is something I should have done first. So I'm going to circle it, just letting you know it's good. We got to try 2 minus root 5 as well. So let's go 2 minus root 5. And we're going to store that. So store it as x. And then we're going to grab that equation again, see if we get 0. And it gives us an error. And the reason it gives us an error is if we go back and we see that this is a negative, right? When we had 2 minus root 5 gives you a negative number. I cannot take the natural log of a negative number. It's not defined there. So actually when I said both of these are solutions, I kind of screwed up there. I didn't notice that that was going to be a negative number because root 5 is bigger than 2. So this is not a solution because it's not defined, right? The natural log function is not defined for any negative numbers. So the only solution we have there is 2 root 5.